Okay, so today I'm going to do this and you do the rest. Okay? There are very many examples, trust me. So let me do this for you. So from our Henderson-Hasselbalch equation, which we have derived together, which says pH is equivalent to pKw or pKa, not pKw, sorry for that, plus logarithm of the concentration of the salt, okay, divide by the concentration of the acid. So from this Henderson-Hasselbalch equation, we have the Ka. Can't you get the pKa? It's simply the negative logarithm of this. From the data given, can't you get a concentration in moles per decimeter cubed of sodium acetate? Yes, you can. You're given in grams per liter. Just convert grams per liter to moles per liter, and you have the answer. You are given the concentration of ethanoic acid. Can't you really do that? So guys, this is some simple work, man. Some simple work. Which shouldn't stress you up. Which shouldn't give you headache. So let's see. Our concentration of the salt, because it is what we need only, and we chill. It is simply, so we shall need the RFM of CH3. Is it acetic sodium acetate? Yes. Sodium ethanoate, which is simply CH3, COO, and then sodium. So whereby sodium is 23. So this is 12 times 2. You should get the answer. Plus, I hope all of us know how to calculate. 16 times 2. 16 is oxygen times 2. Plus, yes, we are remaining with the 3 times 1 times 1 plus 23. I'm just calculating the RFM, okay, times 1. So what is the answer? This is 24. This one is 32. This one is 26. So 24, 26, that's 50, 32, 82. So it is simply 82. Don't put G because you've said RFM. Now from this, 82 grams contain how much? 1 mole. Write full words. Don't do this. Write full words. But how about the 4.1 grams given? So the 4.1 grams given, it will contain 4.1 times 1 out of 82, which is simply 4.1 divided by 82. So how many moles? Moles. So we shall get 0.05 moles. Actually moles. Okay? But the question is, they dissolved 4.1 grams in 1 liter. So that means that this is actually the concentration of our salt, which is sodium acetate, which is simply 0.05 molar, or you can say moles per liter, or you can say moles per decimeters cubed. Now we have this, we have Ka. Can't we get the pH really? Yes, we can. So our pH therefore is gonna be negative logarithm of our Ka, that's pKa, which is 1 point. It is logarithm to base 10 times 10 power negative 5 plus log, everything log of concentration of the salt which is 0.05, divide by concentration of the acid, which is 0.01. It's here. It's 0.01. So what will be the answer? So this one is plus log of 5 of 5. So what is negative log of 1.1, 1.7 times 10 power negative 5? So we shall get 4.76. This is 4.7 6 87 6 956 996. So it is should be equivalent to our pH. You should be the one doing this work. So therefore our pH is going to be you get log of 5 and then plus this. My answer is 5.5. 5.5. So this is my pH of this acidic buffer. And you're not supposed to put units. pH doesn't have units. It does not have units. I repeat, it doesn't have units. So, the preceding questions are yours. I'm done with mine. You do, and then we do. You do, we do. You do, we do. Where you manage to do, then I think there won't be need of doing. Yes. And the question is there. Oh no, you can't do this. This is some wide one. This is some wide question. And I think yes. Now for this one, I'll do only one. Okay? I'll do only one. So now the question wants the pH change of the above solution. Which solution? This one. Okay? Remember its pH is 5.5. So they want us to calculate the change in pH if we add there just a drop 1 centimeter cubed of 1 molar sodium hydroxide. Now for a solution with such an equilibrium, CH3 that has established such an equilibrium. So ionize fully, okay, to give us the base. There is a C here and then minus plus the hydrogen ions, and then the our strong electrolyte, which is C3COO, plus. But you can share with your fellow students. You can share them links to these lessons. In case they can follow, they might get helped. Okay? This is CH3, then COO minus, and then plus sodium ions. Now, if you've attained such an equilibrium, and then from this equilibrium, you simply add 1 drop of sodium ions, of sodium hydroxide. Sorry for that. You simply add there 1 drop of sodium hydroxide. So how will this sodium hydroxide destabilize? How will it affect this equilibrium? In other words, how is it going to be buffered? So in simple terms, the sodium ions, it will bring the hydroxyl ions, because also it's a strong electrolyte, which will fully ionize sodium ions. Okay, sodium hydroxide, it will fully ionize to give us the sodium ions plus the hydroxyl ions. Okay, but the interest is this, because this is the one which would vary the pH. But the hydroxyl ions added, they will be buffered by reacting with the undissociated acid, the excess acid. Okay, it will react with the OH ions that have been added to form the ethanoate, acetate ions, and water. And this water is neutral, that it doesn't affect the pH. So it will be buffered. But now the question wants us to calculate the change in pH. Remember the overall pH was 5.5. Okay? It was 5.5. Don't forget that. So we want to see really how is the change going to be. Now, if you react in the process of buffering, obviously you see that some acid will react with the OH. So there will be a decrease in the concentration of the acid. But also you produce some salts, some ethanoate ions. So there will be an increase in the concentration of ethanoate ions. So that is what we shall find. And we use the two to determine the change in pH. So what will be the increase? So from mole ratio, if you have the moles of OH ions that were added, it is simply, so 1,000, okay, centimeters cubed, oh sorry for that, contain 1 mole. So how about 1 centimeter cubed? It contains 1 out of 1,000, which is simply 0.000, no, this is 1, yes it is, this is not there, moles. So now these are the moles of OH ions that were added. So from mole ratio, we can see that 1 mole of sodium ions reacts with 1 mole of ethanoic acid to produce 1 mole of the salt. So it means that moles of the acid that reacted, it is 1 mole. It's 0.001 moles. Okay, 1 moles. Likewise, moles of the salt that were formed, moles of salt formed, it is also 0.01 mole. 0.1 mole moles. But now the question wants concentration, change in concentration, not number of moles formed. We are not interested in number of moles formed. So back to the question. The question says we are dissolving, okay? Calculate the pH of a buffer solution formed by dissolving 4.1 sodium acetate per liter and a solution of ethanoic acid. So we don't have volumes. So we shall just take this to 1,000. Okay? So moles of, yes. So we are dissolving in a liter. Okay? We are dissolving in a liter. Even the acid. So I think here the total volume is a liter. So therefore, these are the moles of sodium, moles of the, these are moles of the, this is acid in a liter. Also this one, moles of the salt in a liter. So simply if you want the change in concentration, the new concentration, okay, new concentration of the acid is simply the old concentration, which was 0.01 molar, okay, 0.01 molar minus the 0.001 molar. And what will be the answer? Get the answer, molar. Similarly, the new concentration, okay, of the salt that is formed is simply the other old concentration of the salt formed, which was 0.05 molar, which is 0.05 molar, plus here we shall add, because the salt has been formed, plus 0.001 molar. So what are the answers? So without going far, this one is going to be 0.051 molar, and then this one is going to be 0.099, I think, molar. Oh no, it can't be greater than this. This is 0.9. Yes, this is 0.9. Okay, so our concentration is going to be 0.009. So our pH, therefore, the new pH is negative logarithm of our K, Ka, which is 1.7 times 10, our Ka power negative 5, okay, power negative 5, sorry for that, plus log of 0.051 out of 0.009. So what is the new pH? 5.5. Yes, Jordan?
5.
Okay, 5.5. Something? The letters that go past this? Yes, so this is simply 5.2. 2. 223, if I'm to. Now, since the question wants the pH change, it is simply the previous pH, which is 5.5. However, I have a feeling we overround it here. Minus 5. It is the new minus old. Sorry, it is 5.5. This one, 2, 3 minus 5.5. And the pH change therefore is simply, this is 0.0223. Units. Don't put unit, but it's simply 0.0. So the pH changed by 0.023. As simple as that. So guys, let's call it a day. Please subscribe, share with your friends, those who are stranded. Yeah, so that we can all learn together. Have a nice time.